So I'd read in the comment section a couple of days ago where somebody had said something along the lines of, well, Dave was going to make a jet tester and that never happened. Well, yeah, actually it did. We've been working on getting this thing to be perfect. And you got to remember, when you're starting out building something that there is no plans for, there's a lot of things that you have to figure out, and that takes time. Now, fortunately, there was somebody that had reached out to me and had the plans for how the original jet testers had been made, and that was a lifesaver because I needed to know a couple of things about maintaining pressure and flow on the jet that without that, none of the rest of this would work. So they reached out, told me how they did it. I looked over the documentation and it was 100% sound. The problem with it that I have was the part of actually measuring the time duration on the jets was as good as they could do for the time that they had. I wanted to make that a lot more precise. So that took coming up with the correct components and writing some code for an Arduino, which turned out to be a lot more complex than what I would have thought because of the fact that the measuring part of it was one thing that was pretty simple, but figuring out how to make the thing work consistently with the difference in weather conditions, now that was another thing. Now, fortunately, I've already done that both on my dyno and on my airflow bench. So I had an idea of where I was going to start out at, and we took off from there. Okay, so let's turn the electronics of it on. All right, so now it wants me to calibrate the scale, so I'm going to go ahead and go through the calibration setup. Okay, so now here's the beauty of the system. To get a steady state of water, you need it to be running for a while. But then to be able to measure that, and like most people use like a stopwatch or some sort of a timing thing, you'll put the container underneath of it and then start the timer and then pull it out and stop the timer. Now this will get you really close, but I wanted something that was dead on. So what I did was I programmed an Arduino so that it measures the total weight of the vessel that I'm about to fill. And then when I put this in here, I push this button on the side. And what it does is it measures the weight of this container, the water inside of it, at the beginning, and then stops the measurement in 60 seconds. And that gives me a 60-second window of how many cc's or milliliters this thing is going to flow. Now, the beauty with this is there could be water in this container before I started, and it doesn't matter because it measures it at the beginning. It measures the total weight of it at the beginning of the test and the total weight at the end of the test. The thing that I needed to get around was the fact that the RAD, the relative air density, and temperature will change how the medium flows. And in this, we're using water, and we tried different types of water, i.e. distilled water, regular water, filtered water, to see what was going to be the most accurate to come up with a media for that. And so the test is finalized, and we have 311.2 milliliters. Now, what I'm going to do here while we're doing this is I'll just go ahead and take the vessel off of it, move this back, dump it back into the circulation tank. Put this back on, shove it back underneath, and press the start button, and it'll start taking another test. So, coming up with the right type of water to use, also having the sensors that can monitor the density, the temperature, was quintessential with being able to get numbers that are as repeatable as the numbers that we're getting. So to say that I don't complete something, well, maybe I don't get it done in your timeline, but I'm always working on everything. Now, for the people out there that are going to say, okay, well, you're doing it wrong. All right, good. Set up, build something, make a video of it testing jets, and then post your video. Okay, simple as that. Maybe you get different numbers than I do. Maybe your numbers are more accurate than mine are. Or maybe we find that both of our systems work the same. Then there would be two test units that could co-witness each other. So that's your homework assignment. So how is this going to benefit the community? The main reason for building this was to test a hypothesis, something that I've seen on both the AFR and the EGTs on the dyno. Are all jets created equal? Are all jets for key-in? Are they all within a very regimented standard? So what we're going to do is when people send in their carburetors to have them modified, if you will send in from like a 165, 168, 170, 172, 175, so 168 to a 185 of actual key-in marked jets, I would go ahead and, for a limited time obviously, go ahead and measure your jets and come up with a standard. The big thing is to see if you have any jets that are overlapping. So I actually have jets that are key-in marked in my jet kit that I have a 175 that flows less than a 168 does. And I have got a couple of them that actually overlap each other by a little bit. So I have went back through all of my jets and cherry picked the ones that are exact to what the spread should be. Now, you're asking me, okay, Dave, what should the spread be? Right now, as best as I can tell, it's about 4 milliliters. But let's say I have a 162 and a 165, and the 162 is 2 milliliters higher, and the 165 is 2 milliliters lower, then you would change between those two jets and not notice any difference whatsoever. So we need to create a spreadsheet, an Excel spreadsheet, on all the testing data, and that's why I'm allowing people to send in actual key-in jets, real key-in jets, to be tested so that we can create a database of what the lineup should look like. But yeah, to say that I don't get done with stuff is a pretty ignorant statement, because if you see all the stuff that I'm doing, you'd realize there's a lot of stuff to be done. So I hope this clears up some misinformation. I mean, anybody that's been around me for the last 40 years knows I'm working on something all the time. But yeah, we want to create a database. So if you have key-in jets and you're sending your carburetor in to be modified, and we'll test them, mark them, and send them back to you. And this will help to add to the database of jets. So thanks, guys. And now I'm going to get on the next project.